Hello everyone, right, in this video I'm going to start the introduction to Unit 14C. It's going to be a much shorter unit, much shorter assignment than what we've previously been doing. I'm going to give you a lot more freedom in how to do it. But before we do that, I'm going to show you everything that I've made for it. So what I've got here for you is the lesson notes, just as usual. This is a summary of what we're going to cover. And in 14C, we're now looking at the isomers of different compounds and how that affects industry and how it can affect therapeutic things moving forward. So things like how drugs are affected by isomers and the importance of that. And that's what 14C looks at. Just to give you guys a bit of an idea of where this is going, this here is the specification from the exam board. I will send it to you, so I'm not going to read it here because it's just a little bit long, a little bit boring. But this is exactly what your assignment needs to include. So I'm going to send you over this as well, so you can keep relating back to this to make sure that you've got all the boxes that are covered in this task area here. This vocation scenario and context, it's unimportant. I don't know why they've done that, but we're not going to pay any attention for that. What we do care about is the task, and how I've broken it down is going to be in the videos 1, 2, and 3. The checklist of the evidence is things like this, and again, everything I've done in terms of setting this up will lead you to tick all of these boxes. So don't worry too much about that if you don't want to use this. But if you do, this gives you an idea of what looking at the specification might be like when it comes to doing assignments at university, because this is pretty much what they give you, and then you have to go off and do your own. This is going to cover pass, merit, and distinction criteria, and the way that I planned it is that everyone who does the pass criteria will automatically get the merit criteria as well, and you'll see that as I go through it. As normal, we also have a PowerPoint made by Dr. Solomon. So I'm still going to refer back to this because it's still great. It hits all the points that we need, and it doesn't really have anything else in there that's waffly. It's just straight to the point. So Unit 14 is understanding the type, structures, reactions, uses, and properties of isomers, and this is the pass criteria. So isomerism, first of all, we need to define what is a structural isomer, and this right here is your definition. Now, I don't mind if you use this exact definition because that's exactly what it is, or you can go find another chemistry-based definition online and use that as a reference. That's good as well. Either way, so long as you have something that relates to the fact that we're now looking at the same molecular formula, but a different structural formula. So same molecular formula, it means it has the same amount of carbons, hydrogens, any other elements that are in there. However, they're arranged in different space. For the first section, we're going to be looking at structural isomers, and that's what the first lesson is going to cover. And there are 3 types of structural isomers, and we looked at this in Unit 5A2. So we've got chain isomers, which is one of these. This is a chain isomer, where we have a carbon compound like this. However, the isomer of that is one of these carbon chains is now been moved to a center carbon like this, and we have this from here. So here we've got a pentane, and then here we have a methylbutane, 2-methylbutane, which it'll always be. The next lesson, so lesson 2, we're going to look at stereoisomers, and then lesson 3, we're going to look at the distinction criteria. So you can see there's not actually a lot to this assignment, but there is going to be quite a lot for us to do. The first task we're going to do is we need to write down an introduction to structural isomers. What are the 3 types? And then we're going to start putting them together and how we go along that. So first of all, we have structural isomers. And the first one we're going to look at is a chain isomer. This is a structural isomer where the difference is branched and unbranched. So it's the same number of carbons and hydrogens, only one has a branch, like this, and then the other one does not. When I'm asking you guys to do this, again, I want you to pick a different amount of carbons that I've chosen and do a little bit of research on that. So you can do propane, which could look something like this. 1, 2, 3. And then 1, 2, oops. Sorry, you could butane. 1, 2, 3, 4. 1, 2, 3. So there you have methyl, propane, and butane. Then you could do hexane. 1, 2, 3, 4, 5, 6. And then you could do a branched chain of that. So 1, 2, 3, 4, 5, and do that one there. And you can do any variation of an alkane and a branched alkane. It's completely up to you which ones you want to use. You just need to pick some for me. And again, when we go back to our summary notes, I'll show you that. So we go here. We've got structural isomers, introduction, what is a structural isomer, list 3 types, give me a reference. Chain isomers is our next section. That's the section I'm on now. We're going to define what a chain isomer is, and then we're going to list 2 examples of 2 different alkane chains. And I've given you one as an example that you can all use. The structure that I'm going to use to teach you guys this, and I think the best way of doing this and putting this into our assignments, is that we're going to be using the name and molecular formula, the skeletal formula, and then we need to put together a molymod of our compound. And we get the molymod in class, so you're going to have to come to classroom to put those together, but I'm going to find a different way of managing our time around that. Once you've done that, you're going to take a picture of that. That's going to go into your assignment as figure 1, 2, 3, 4, whatever it is. And then below that, you can then list its chemical and physical properties. And I would just do this in a table. Then below that, you're going to be doing the importance of industry in chain isomers. Why are chain isomers important in industry? How does it matter? What are the differences? And I'm going to relate this one to the petrochemical industry because it's easy to talk about. What are the intermolecular forces between branched and unbranched? What's the difficulty in bond breaking between branched and unbranched? And then talk about fuel efficiency, which is the better fuel. To give you some additional information on that, you've got this page here, which I'll send separately. But this is the Unit 5 A2 booklet, and a digital copy is available on Teams using these links. But you're more interested in this section here. So I would start off by watching these videos here, 13 and 14, to give you an idea of what we're going to be writing about in 14C's assignment overall. If you need a bit more help on the isomers, these videos will help. The booklets will also help, and if you need even more help, you can always just come to me and I'll give you the rest of the information that we need. So we've got these here like this, and what I want this to look like in our assignments is something like this. So I've got an assignment outline for you this time. We've got my title, introduction, structural isomers, that's my definition, there's my reference. Then 1.1, chain isomers. What is a chain isomer? And then here you can see what I've done is I've got a picture of my molymod. This is pentane, 1, 2, 3, 4, 5, with the hydrogens all attached. 1, 2, 3, 1, 2, 1, 2, 1, 2, 1, 2, 3. I put that on a piece of paper, took a picture of it, and on that piece of paper, what I should have done is written the name of the compound, the molecular formula, and the skeletal formula of what I'm putting together as a molymod. And I've got my name and pin in the corner as an example. Then below that, figure 1, molymod of pentane. The next thing I'm going to do is the chain isomer of pentane. So here's going to be 2-methylbutane, C5H12 again. This is what it should look like, and this is what it looks like here as a molymod. Took a picture of that, stick it in my assignment. Figure 2 shows this, this, this. Then you can do it again with 2 more examples of your choice. Here it says propane, that should be butane. Butane to nonane, pick one of those. Use that CnH2n formula to work out what's the molecular formula of your chosen compound, and then you need to draw me the skeletal formula of that. Again, assemble it, take a picture of it, put it into your assignment. Figure 3 shows this. Then you need to change the arrangement of that by removing one of those carbons, attaching it somewhere else on your molymod, and then drawing and writing the name of that, the molecular formula and structure formula of that. Below that, you can then list its physical properties, boiling point, physical properties, and chemical properties. For the alkanes, I'm not too interested in the chemical properties because it's quite boring. There's not really that many of them. So I'm not too interested in this section here. But for this, a table makes it really nice and easy to do that. The boiling points can all be Googled. Once you know the name, just Google the name, what's the boiling point, stick that in there, and then you got physical properties with a reference. Finally, the importance of industry in chain isomers, and I'm going to show you how to put together that. So, we're going to go to this section here. So this is the images that I've just shown you. They shouldn't take long in class. It's going to be this little bit here. The importance in industry, this is merit criteria, but I think it's more important to just stick it in there. We're going to have a paragraph on the importance of branched isomers in the petrochemical industry, and we need to discuss these things: intermolecular force, difficulty in bond breaking, and fuel efficiency. The video that I've shown you in 13 and 14 from Unit 5 covers this section really well. Watch that video, and there's your information. If you need some more, you can always Google some of these questions here in relation to what you need. And that's that section done. Now for the next two set of isomers, structural isomers, it's the exact same pattern, but now we're just looking at different isomers. So the next section we've got is positional isomers, and you've got the same thing here. So I'm going to show you what I've got. So down here, we've got positional isomers. Again, you're going to have 4 images of these, and you're going to have 2 sets of basically pairs of isomers. And then below that, you're going to have a table, and then tell me the importance of the positional isomers. To give you some more information on that, the positional isomers we're going to look at is one hydroxy example, so one alcohol example, and one halogen example. And to give you a brief idea while I've got you, 1, 2, 3, 4. Here is a secondary alcohol. There we go. Here's my secondary alcohol. And 1, 2, 3, 4. Here is my primary alcohol. So that's primary, and that is secondary. Now these are both isomers. They are positional isomers because this functional group here is in a different position in my other compound. And because of that, they're going to have slightly different properties, and that's for you to talk about in your physical properties and your chemical properties. The other series of pairs I'm interested in looking at are halogens. Keep that as a primary. And you can look at fluorine, you could do chlorine, you could do bromine. I don't mind which ones you pick. And you can give me an example of a primary or secondary isomer of one of those. And that's good as well. And that's basically what I'm looking at for this section here. I'm going to put those together in class, take a picture of them, and then we're going to write down our physical and chemical properties. The importance of industry of the positional isomers is a very, very similar discussion. We're going to have a paragraph of the importance of positional isomers of alcohols and their oxidation products. So I want you to tell me what's the difference of me reacting a primary alcohol, secondary alcohol, and a tertiary alcohol. So in the context of oxidation. This is something we did in 14A, so it might seem familiar to those who are going to do some of the research on that as well. For this, I want you to discuss what's a primary, secondary, tertiary alcohol. I want you to tell me what are the oxidation products of a primary, secondary, and tertiary alcohol. Is it a ketone? Is it a carboxylic acid? Is it an aldehyde? Is there no reaction? That kind of stuff. And then finally, relate that to the importance of choosing the correct isomer to produce a carboxylic acid or a ketone. So if you're a company, which one of these primary, secondary, tertiaries would you want to use in order to form carboxylic acids or to form ketones? And put that together in a paragraph for me. And you can use a diagram if you want as well. The last section we're going to look at is to do with functional isomers. This is 1.3, functional isomers. Again, same pattern over and over again. What's a functional isomer? Give me some examples with the mods and the drawings, a table of their properties and chemical properties, and then finally, importance in industry. So just so you can see the repetition here. 1.3, functional isomers. Pink, there's my definition writing. Then I'm going to have 4 of these images with my mods in there. My table with my name, boiling point, physical and chemical properties, references, and the importance of industry, functional isomers, my explanation down here below. To give you a bit more detail on that, in 1.3, we've got define what a functional isomer is. So tell me what exactly is a functional isomer. And then I want you to give me 2 different examples, one pair using a carbonyl, and one pair using an alkene and a cycloalkane. To give you an example of that, a carbonyl example could be something like 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Here I have a ketone, I have hexanone, and an isomer of that would be 1, 2, 3, 4, 5, 6. And that's my aldehyde, and that's hexanal. So that's hexanone, and that's going to be hexanal. All right, they are they're functional isomers. They're functionally different. An aldehyde and a ketone are functionally different. However, their molecular formula, the amount of carbons, hydrogens, and oxygens they have are the exact same. So that's why they're different there. The other example I'm interested in is one that's slightly weirder, and it's an alkene and a cycloalkane. And again, this all relates back to things we've done in Unit 5. So 1, 2, 3, 4, 5. Let's do that one there. And then the functional isomer of that, I'm going to make things a little bit easier. I'm just going to cheat. 1, 2, 3, 4. And a functional isomer of this is 1, 2, 3, 4. So here I have 1, 2, 3, 4. I have butene. And the other functional isomer of that is cyclobutane. So it's the same number of carbons and hydrogens in both of these. However, functionally, they are very, very different. They will react very, very differently. And you can discuss that as well in some of your merit discussion a little bit later down below. Once you've done that and you put together your mods and taking pictures of them, you're going to put together your table, your physical properties, boiling point, state, colour, that kind of stuff. Take a picture of it all. Don't write that all up, and then you can move on to the next section, which is the importance of industry, functional isomers. A paragraph on the importance of functional isomers of carbonyls or alkenes. Here, I just want you to pick one to discuss. I don't want you to discuss both of them. That's too much. And I think picking one is just a lot easier. If you want to talk about the alkanes, not the alkanes, the carbonyls, you need to talk about an aldehyde and a ketone. And here you're going to tell me the differences between an aldehyde and ketone structurally and reactivity-wise. How are they both different? And you're going to have to do a bit of research for that. The differences in the uses of aldehydes and ketones. So how are they different in their use? And then I want you to relate to the importance of industry of using the correct isomer. So for example, if you're a company that makes acids, which one of these would you most want to use in order to produce acids? That kind of stuff. The other side of that is you could talk about alkenes and cycloalkanes. Here, tell me the differences in their uses of an alkene and a cycloalkane. What's the difference, how they're used? Then differences in the products of reacting alkenes and cycloalkanes, which you can see here above. So this one covers that example there. So here we're reacting it with chlorine. The alkene gives me a dichloro, and the cycloalkane gives me just a chloro. It gives me a haloalkane. So they're going to have different reactivities, different products. They're going to be used for different things. And then I want you to relate to the importance of industry using the correct isomer. So you just need a sentence or two just saying, obviously, if you want to make this product, you wouldn't then be able to use an alkene because you would make this product, not this product, and therefore you'd waste money not making this product. I mean, it's kind of repetitive, but that covers the base of it, the base of what you're talking about. I'm going to send you all these stuff separately so you can all have a look at it side by side, whether it's on a phone or laptop while you're typing it up, taking pictures of it, whatever it is. And I've got pretty much everything you need. It just needs to be done as soon as you can do it, because then we're going to move on to the next section, which is stereoisomers, slightly shorter section, but more difficult to write about. And then we've got the distinction work to do. All right, guys, I'm going to leave you with that. If you've got any questions, then send them over my way. But otherwise, I'll see you guys soon.